Hello, I'm Ara.
And I'm Ronica.
And we have a new session of math explaining you the mean value theorem.
So we're going to start by telling you guys what the mean value theorem is, and then we'll give you guys a visual image of it just so you guys can understand it, and then we'll move on and do some examples. So the mean value theorem has two conditions that must be satisfied. Let's suppose f is a function that satisfies the two following hypotheses. Our first condition in the mean value theorem says that our function f must be continuous on the closed interval a, b. I'm just going to underline closed because all that means is that in our interval, a, b must be included. So suppose we have a graph that looks something like this. This is our function f of x, and we have a point A right here and a point B right here. So if we wanted to see if this function is continuous, I would say the easiest way that would be is to start from A, just trace it. Yes, the graph is continuous, it doesn't cut anywhere, all the way until we get to point E, including that point. It is continuous, the graph does not stop anywhere. Let me give you guys an example of something that would not satisfy this condition, just so you guys can see the difference. So say we have a graph that looks like this. This would be our f of x, this would be point A, let's say, this would be B. So you start by saying, well, does this satisfy the first condition? Let's try. We go, we see it's continuous up to this point, and then we have a jump discontinuity, and we're not at B yet, so that means it does not continuously go all the way until point B. A graph like this would not satisfy that first condition. So now that we hopefully understand the first condition, let me go ahead and write down the second condition of the mean value theorem. The second condition simply says that our function f is differentiable on the open interval a, b. So what the second condition of the mean value theorem says that for any point in between a and b, not including a and b, you must be able to take the derivative. So once these two conditions are met, we can go ahead and move on and explain to you what the mean value theorem actually is, and Ara will be able to do that for you guys.
So to conclude the mean value theorem, we should write first of all the following down. F prime of C equals to F of B subtracted by F of A over B minus A. So what does this actually mean? Let's first graph a function. Let's draw a function. Looking approximately like this. This is our y, this is our x. So let's pick a point on x where we say it's a. So let's say here's our a. Here automatically we would get our f of a. And on this point we would have b, and we would get here f of b. So if I am now drawing a line between those 2 points, what would I get? I would get the average slope between these 2 points of the function, between a and b. How do I get the average slope? The slope is nothing else than rise over run. So if I make a line until here, let's take this one, and I take this difference, I get my raise, and I take this difference, I get my run. So maybe you remember from your algebra classes this following equation. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the same meaning as this because we're doing nothing else than taking our f of b, subtracting by our f of a, so we get the raise, and we're subtracting our b from our a, so we get this distance. So now we are having our average slope. We also need our derivative of the function. So why is that? The meaning of the mean value theorem is nothing else that we must have a point C between a and b where the derivative of the function is the same as the average slope of the function. So suppose the point is right here and you make a line, this derivative. And this line would be supposed to be parallel to our average slope. That's why we have this equal sign here. Our derivative is the same as our average slope. So maybe an application would help to understand this concept. So let's say this function, this black function here, is a graph of velocity. And I would drive my bike, I would ride my bike to my friend's house, and when I arrive at f of b, he asks me for my average speed. And my average speed would be nothing else than my average slope from my house to my friend's house. So if I say my average speed was from maybe, let's say 19 miles per hour, that would mean that the distance between my house and my friend's position, I was at a speed at least one time where I was actually riding 19 miles per hour or maybe faster. So that makes sense too, right? Because how can I get my average speed of 19 miles per hour without actually ever reached that 19 miles? If I was the whole time riding my bike at a speed of 10 miles or 12 miles, I cannot even get my average speed of 19 miles. So that is actually the mean value theory, that if I have my average, there must be a point in between those 2 points that it has the same slope as my average slope. Let's do some examples now, and Veronica will do the first one, yeah? And use the marker. We have to erase this.
Yeah.
Should I erase this too?
No,